Hi guys, and welcome back to Wade's Workshop. And another episode of Shed Talk. We haven't done one of these in some time. There's going to be a bit of turning in this one, I think, mostly. But yeah, bits and bobs and what have you. As you can see, I've got this new fashion going on with the one-armed glasses. Yeah, I took a tumble, a week or so ago now in the shower. Now, I wasn't wearing my glasses, but my glasses were on the edge of the bathtub, and my shower is over the top of the bathtub. I took a slip, fell down, smashed my glasses, and actually cracked 2 ribs as well. So I've been a bit uncomfortable for the last week or two. As long as I don't burst out laughing or sneeze or cough hard, everything's fine. So yeah, so it hasn't been the best couple of weeks, and broke my glasses along at the same time. My new pair are coming tomorrow, I think. So yeah, I was due for a new prescription anyway, otherwise I would have arrow-dated them all up, as they say. Right, okay. That would have been a bit mean, wouldn't it? A bit of elastoplast around it to hold it together. New arrivals to the shop. Website called Zorro. I've been dealing with not the website. We used to have a rep come into several of the companies I've worked for over the years. British company Cromwell Tools. Now they have got their own website, but it is Zorro, which is a UK website. It's a tool website. It's not predominantly Asian products, shall we say, and obviously they have the age-old name of Kennedy. Kennedy tools are all from Zorro. So I ordered a couple of tap wrenches, ratchet tap wrenches, useful in the mill. One of them, this one is, what does it say? Oh dear me. There it is. Does M3 to M6, that sort of range. I haven't actually opened the packet yet, but I've seen a little job I need to do on them already. Oh God, ribs. Yeah, ratcheting tap wrench. You know the score. You've got a reverse ratchet and a forward ratchet on the spindle here for tapping. Yeah, and you can reverse the action, or you can lock it central. I probably will use it lock central more than anything if I'm tapping in the mill or in the lathe. Now, there's no hole in the back end for a centre. I haven't made a tap follower, sprung-loaded tap follower, but it's something I'm going to have to make. I won't be showing that because I think everybody and his dog has made one of those over the years on YouTube. So I'll knock one of those up. But yeah, holds taps, one for 3 to 6, and a larger one that does M5 to M8 taps. So yeah, I don't do much bigger than M8, and I've got bigger tap wrenches if I'm going up that size. These wouldn't have enough torque for M10, as it were. But yeah, a couple of, there's the larger one, there's his big brother, and he hasn't got a hole in the end either. But again, ratcheting tap wrenches. I do like these. I've had one, some time ago. I can't think of when I had it last. 10 years since it's disappeared. Probably left my toolbox open one day and somebody took a fancy to it, I would have thought. So that's those. I've got a couple more new things over there. I'll keep those by. I won't spoil the next bit of the video. You'll be able to see what they're for. And I was watching, I don't know who it was the other day on YouTube, and they talked about insert vices. So small vices that you can put in your vice. So insert in your vice. So I've got a little insert vice here. Again, keyless vice. As you can see, it's very small. Again, it wasn't expensive. What is it? The width of the vice. 34 mil. I bet it's imperial. Hold on, what's that reading? 1.335. No, it's not imperial either. Anyway, yeah, it's let's go back to metric, because imperial nowadays cracks me up. 34 mil wide. It's 35 mil high, and its overall length is 75 mil. So yeah, I would imagine it is it is a metric vise. But yeah, a little insert vise. I've got plans for this. I was thinking of making a little adjustable sign table, something like that, to put the little insert vise on, something where this will drop in and locate, get locked in, and it can be taken off, used in a normal vise, used as a mini vise, or put into a little sign table. I was thinking of making a sign table. Again, sign table, oh, it's been quite a big project, expensive on materials and what have you, and when I'm spending money on tools instead of things like that, I don't want to be spending money on materials, but that's another story. Anyway, let's get on and show you the story of, shall we call it, drill chucks in the milling machine. So, enjoy, guys. So, a little story about chucks in the mill. When the mill arrived, it came with a chuck in a box, and it's a 3 to 16 mil B16 taper in it, and it's a Sanu. Nothing wrong with the chuck. Yeah, quite happy with it. It runs true enough. Yeah, absolutely fine. However, the arbor that was supplied with the B16 to MT3 for my spindle has got an M10 thread in the end, whereas everything I've got has got MT3 with an M12 thread in the end. So this annoys me because every time I've got to change the chuck back to anything else with the MT3, I've got to change the drawbar as well. Now the mill was supplied with an M10 and an M12 drawbar, but it's just slow change around. So I've got a bit of a plan. I want to fit a keyless chuck on here, which I have a keyless chuck, again with a B16 taper in it. So I'm going to get myself an arbor. I'm going to buy the arbor, so there's no tool making there. B16 to MT3 with an M12, and I know I can just pop this chuck in and happy days, no change in the drawbar. Added bonus is, this chuck I always used to use on the lathe, and it was a little bit long. It was always a bit of a problem because of its overall length, whereas this one's shorter, be better suited to the lathe, and we'll go straight onto this arbor MT2 to go in the lathe. So that's plan A with the chucks. So the other plan is I have this really nice Rohm, R-O-H-M chuck, and it's on an MT1 Morse taper. I could basically change the arbor, put a couple of sleeves in, what have you, and put it up in the MT3. What I want to do is get this chuck so that it fits into the ER32 collet. So when I got the ER32 collet up, the most common collet size I use is an M12. So if I had an M12 arbor on here, it could go straight in the collet, and I got the availability for drilling. So we need to make an arbor. Oddly, made in Germany, a Rohm chuck, I've already loosened it off, has a 3824 imperial thread in it. It's a 3824 arbor. Okay. I'm surprised it's not metric, you know, maybe 10 mil, but still, okay, fine. M10 fine, something like that. Right. I haven't got a 3824 die. My lathe won't do 24 TPI, so I've ordered a 3824 die, a split die. Okay, so that's part 2 of the scenario. So I need to draw up something that'll go in there instead of that with a 12mm shank. I've got a piece of 01, just happens to be what I've got lying about, so I'm going to make it out of this piece of 01. So I've got my little sketch, 12mm diameter here to go into the ER32 collet, and a major diameter of 16mm here, which is the shoulder that screws against the chuck face. So we need to turn back 44.5 back, at least 44.5, might be 50, at 16 diameter to start with. So I'm going to start by centre drilling the end of the bar. I've got enough sticking out to part this whole part off once I've done these 2 diameters. So centre drill the end, and we'll skim that to 16mm. Let's get a rough idea of where we are. 19.2. Okay. So I'm going to take 2mm off the diameter. in one hit. So that's 1 on the readout. Way to go again. So quick measure up. I'm going to try and take 2 equal cuts to finish it off. That's measuring 17 mil on the nose. It's not a critical diameter, so I'm going to take 0.25 aside. I'll just reset my DRO. That's 0.25 on the DRO. Nice bit of cutting fluid. So I'll take this cut, it should leave me at 16.5, and another cut identical in size. Yep, 16.48, so another 0.25 cut will bring us in the ballpark. .03. Okay, we'll live with that. So I've set my DRO to 0 on that diameter, which is 16, and the diameter going to the collet is 12, so I know I've got to take 2 mil aside off. So I'll start with 1 mil aside off, and then 2 half mil aside cuts. So there's the 1 mil. If I go back to my drawing, the overall length was 40 millimeters. So this will drop it to 14 mil over 40 millimeters. So I'm going to try and take this in 2 cuts. So I've got 0.55 to come off. So I'm going to take 0.25 off, first of all. And I know it's a source of annoyance, but I'm going to have to use the power feed, which makes a horrible noise on camera. It's not as bad in real life, but I'm going to be turning the power feed on. But I am going to be changing this motor to a NEMA motor with a stepper driver, that sort of idea, and that will remove that noise issue that you've got. Can't even put my hand over it to stop the noise. But it probably makes about the same amount of noise as the drivetrain in the headstock if I were to have that connected. So yeah, for some reason it comes out very loud on camera. So this should leave me with about 0.25. Last little bit, I'm taking it to 39.9 mil, and I'll face the shoulder as the last thing I do. Okay. Again, the length isn't critical. The length isn't critical. It's basically the size of an ER32 collet, so it fits right through. So where are we on diameter, and where are we on temperature? Temperature is still cold. So 12.202. So I think we're going to take 0.1 aside. And if it's a little bit up, there we are. If it's a little bit up, bit of Scotch-Brite, bit of polish would probably be perfect. So we should be somewhere near now. We've got a lovely finish on there. We should be around the 12mm mark. I'd sooner be a little bit under than above, because it's going in a 12mm collet. Well, that's all right. 11.978. I think we can live with that. So no polishing required. So chamfer on the end now, and I think a little one on that shoulder. So up with a chamfering tool, which is, where are you hiding? There you are. So a little chamfer on that edge there. I think the tip is gone in that chamfering tool. I might be wrong. It has. Oh, I can see a great big chip out of it. Okay, let's change that tip. So, new tip in place. You won't see this one here, I don't think. Oh, that's much better. Okay, and I'll just take that edge off there as well. Okay. So I need to part it off now. So the overall length of my part is 61mm. I'm going to part it off at 63. So, onwards and upwards. See how we get on with this stuff. Just lock my carriage. Nearly through. Just going to remove my centre and a bit more oil. Let's finish parting it off. Okie doke, there it is. So I've got the collet chuck up now, the one it's going to fit in. Oh, that's a nice fit in there. Okie dokie. Just do the collet up. Bit more. So this is the collet chuck it's actually going to be running in use. It's the one I use in the mill. So I think the first thing we'll do is remove that larger diameter off there. We'll skim it back. And we need to leave 4.5mm of that 16mm that we turned before. So that's fine. And our diameter we're going to be going to is 9.8mm. So, just explain the 9.8. The back of the chuck has a little register in it. And I've measured it up. And a 9.8 fits in there just nice. The original one didn't pick up on the register, the original arbor, but I think I'm going to have a little area 2.5mm wide that picks up on that register to keep it true, rather than relying on the thread to keep it true. Okay, I'm just going to rough this down now. That's 2mm a side coming off. And they're running at about 800 RPM. You could probably go faster than that, but you get a nice curly swarf, but not breaking the chips, but they are falling off in strings. The internal measurement I did of the size of the chuck was with the calipers. So it just goes to show you, don't believe everything the calipers tells you. You know what, that is just trying. That is just trying. If I can take the tiniest little bit more, same cut as I did last time, I think we've got it. Don't act like doing little scratch cuts to finish to a size. I'd rather sort of take 0.1, take another 0.1 done. But needs must when you were aiming at the wrong size. It's still cold. 9.75. So it's a couple of thou down. A couple of thou, 0.05 down. Yeah, it just enters. Okay. So we know we've got our diameter right. I need to face that back shoulder now. So I'm just going to set a 0 on my DRO. And I'm just going to take a scratch pass across this shoulder from about here. And I want to clean this shoulder up nice. So only touching the outside edge there. Still. Nearly there. Another couple of thou. That's good. Okay. So from that shoulder, I want a overall length of, let me see, 14, 15, 16.5 mil. So I'll set a 0 there, come back to 16.5 and just reduce the overall length where we parted it off. So 17.8. 17.1. That's 16.57. And re-zero it, 16.5. Okay, so 3/8. I need a diameter of 3/8 over a length of 14 mil. So I just looked up the depth. It's about 25.5 thou, which is let's have a look. Well, it's 0.5 is 20, 0.6, so about 0.3 aside will be fine. So I'm going to go back to my 0. And go 0.3 deep. There, and then come back just for a bit of an undercut at the end of the thread. That should do me, probably about 2.5 mil wide. I just need to break the corner of that register. It's very small. Just want to break the corner of it. So I'm going to use a needle file for that, I think. Because my old eyes won't see my way into there, I don't think, anymore. Or maybe they will. So a nice lead in for the die. Should do me. Get the dirt off the end of there. See if I can pick up in the bottom of there. Tool won't reach. Okay, never mind. I'll put a sharpener on here while I'm at it. I nearly forgot to mention. Oh, you would have seen me a while back when I was making the quill plate. I made the DTI stand that goes in the quill plate. And I didn't have any 3/8 drill rod or silver steel, and I'd used a piece of brass temporarily just to make the part up. And I actually ordered a piece of silver steel, again on the same order from Zorro. Now silver steel, I've only ever bought silver steel round bar in this sort of standard lengths. I mean, years ago it used to be all made by Stubbs of Sheffield. It was Stubbs was their silver steel. It's the best, still is, if you can ever come across it. However, the lengths were always metric or imperial, depending on what you wanted, or ground drill rod, silver steel as I call it. 01 is the material. and they were always 13 inches long, so you could have, you know, an inch or 25mm. It was 13-inch long pieces. So with this in mind, I'd never bought anything any different. Looked on Zorro. I wanted a piece of 3/8 to, you know, make a piece of rod for the DTI stand. I saw a piece there, 3/8 silver steel. That's what I'm after. About £11, I think, for a piece, and I didn't think that was unreasonable. You know, it's not like I'm buying 20 of them. It was a one-off piece. Anyway, yeah, I didn't think it was unreasonable. Anyway, the parcel arrived, and I thought, well, that's not 13 inches long. I haven't actually opened it up yet. But yeah, I mean, the parcel arrived, and it is, well, I believe it was 900mm. So yeah, I was getting 3 pieces of what I was thinking, you know. So yeah, 3/8 silver steel, arrived in a cardboard tube from Zorro. 900mm, I believe it is. Let me just double check that, because I'm guessing, and you shouldn't guess with these things, you should know. I'm guessing that tube is not a meter, but it's pushing that. Unless, of course, there's only a very short piece in this big long box, but I can tell by the weight of it that it is a... Oh, yeah, nicely packaged, piece of silver steel, looks perfect. It's actually stamped. T&A Precision 3/8, BS 1407, cast BC 6734, whatever that's supposed to mean. And the length of it, let me grab a tape. Must have tidied up because everything's where it should be. And it is, in fact, it's a meter. So yeah, a meter of it for like £11. So yeah, I think I found my new source of 01 is going to be from Zorro rather than eBay and what have you. Can't fault it for the price. And I'm sure we'll see bits of this turning up in several projects as we go along. Bit of cutting edge on there. No. How about that face? Okay. That's just a little break edge on the front of the register there that's going to fit the chuck body. So, I think other than putting a thread on it, we are there. Just with hindsight, I think I'm going to take a little skim off the top of that diameter just to remove it just under 3/8, maybe like 371, something like that. Probably being a bit close on 3/8 with the OD of that, as it's not a performing thread other than for holding it on, because we've got the register 3717. That's yeah, that's more like it. So here we are about 5 days later. It's an imperial die, inch diameter OD, and I haven't got on my die holder for the tailstock. It takes 25mm. Let me just explain. Yeah, here's the die holder I use in my tailstock, and it's a 20 for metric dice, and it takes 25mm diameter dice, whereas this imperial one is a 1-inch. So I'm having to use a normal die stock, and I'm using the quill to keep it in line. So yeah, keeping it flooded with cutting fluid. I'm using a spanner on the tailstock rather than my winding handle on the tailstock. No, on the back of the headstock. Purely because I've got a drawbar in there. I can't use my winding handle, and the drawbar's in there because I'm using the 32 collet. So chemical bluing. I get asked pretty much every time I do a bit of chemical bluing by people who haven't seen previous videos, or I've explained what I use. So okay, let me show. This is, what is it called? Black Oxide solution. And the website is where I got it, and it's a 1 litre bottle. and I've probably over the past 2 years used 100 mil. And the website is Caswell Europe, CASWELL, Caswell Europe, and all sorts of fluids and what have you. You know, they do cleaning fluids, they do all sorts of preparation fluids for using this stuff. Don't bother with any of that. The only important thing is to degrease the part thoroughly. Now you can do that in, you know, a bit of methylated spirits, you know, any brake cleaner I quite often use. Spray brake or carburetor cleaner does the job. But what I've found is Tesco's multi-surface cleaner anti-bac. This is apple smell, very nice. I clean everything with this in the workshop, you know, worktops, the lot. And yeah, it smells nice, and as long as you give it a good soaking in it, wipe it off and don't touch it with your fingers, the part. You know, obviously if it's heavily oiled or greasy, give it a good wipe off, perhaps a bit of petrol, soak it off first, let it evaporate. Give it a squirt with this stuff, any of the anti-bac stuff, or, you know, multi-surface cleaner that cuts through grease and dirt, I think, you know, whatever, does the job. So yeah, let it dry off, wipe any film off. I don't tend to wear rubber gloves when I'm doing it. I've always got loads of blue roll. I make sure it's all wiped with blue roll. Don't touch it with my fingers, and drop it in the fluid. I got a little pot of fluid here with the part in it. It's been sat in there for maybe 5-10 minutes maybe. I think it's mixed up something like 25 to 1 with this stuff. So if you use 100 mil of it, 2.5 litres of the stuff you'd have. So yeah, 25 to 1. Right, okay. So I only ever make up tiny amounts, a couple 100 mil at a time, with a few capfuls of that. Obviously 25 to 1, it goes a long way. It's not cheap, but it goes a long way. I know the Americans use like Oxide blue and apply it with a cotton bud and all that. This stuff, just chuck it in, leave it do its thing. So it's been in there 10 minutes now, and basically you can see it's black. And I throw it in some water. I've got a pot here, again, washing tablet pods or what have you, useful for containers. I keep hold of those. I got a few of them laying around in the workshop here somewhere. Every time we use one of those I hang on to it. I think it's called recycling, the recycled plastic. So leave that in there for 5 minutes. Not even 5 minutes, give it a shake about. Let's put the lid back on that. I'll throw that water away and put some fresh in it for next time. So I can touch it now. I'll wipe that off. Okay. And then I'll get my oil can. 2 seconds. Need some wood if I can find it, yeah. So I'll get the oil can and just smear it with a bit of oil. Make sure it's right into the threads everywhere. Wipe off the excess. If you've got sort of a polished surface, like this was very shiny, tends to come out more grey. You can, I've got a bit of wire wool here, which I keep, 00 wire wool, the finest stuff. You can give it a rub over. Degrease it again, put it back in the tank, and you get, it gets darker and darker with every application. So yeah, chemical blued. So I've just poured the solution back into this big pot, and it does get like black dusty grit into it. I leave it in the pot, it's an old yogurt pot, leave it to settle, all the black muck goes to the bottom, and then I pour the clean fluid back into a small container, old milling cutter container, for my bluing, and then basically chuck it back in and use it next time. Okay, metric clock, 90 to 0 is 0.1 of a millimeter, roughly 4 thou. So yeah, I've got just over, probably about 0.06 millimeters, just over 2 thou. Yeah, when you combine up, let me come out a little. I suppose when you combine up, we've got the spindle to the ER32, the ER32 to the collet to the chuck to the bit. Add them all up. if I've got 2 thou there, I think as a general everyday usable drill chuck that'll go straight in the ER32 collet, I think we're on a winner. Well, there we are, a handy little 0 to 1/4 inch chuck, nice Rome chuck to go into the ER32 in the mill. Happy days. Thanks for watching, guys. Thanks for subscribing, and we will see you all very soon. Cheers now.